Welcome to today's deep dive. We are unpacking a brief from Podcaster Capital titled 1.5 degrees Celsius Countdown. And the mission for you today is simple. We need to understand why 1.5 degrees of warming is basically the absolute defining threshold for our century.
Okay, let's unpack this, because when we think about thresholds, we usually expect to see a cliff, right?
Right, yeah. Like 1 minute you are on solid ground.
And the next you are just falling. You're either safe or you're totally doomed.
Exactly. It's human nature to look for that clear, bright line of danger. We love a binary, but the global climate system, it just simply doesn't operate like a light switch.
Right, which means that cliff metaphor completely falls apart. It's much more like driving through a neighborhood. Going just a fraction over the speed limit doesn't cause your car to instantly explode.
No, obviously not. But the risk of deadly consequences skyrockets with every single tick of the speedometer. So if we're driving through this neighborhood, we're essentially staring at a fork in the road. One path stabilizes at that 1.5 degree mark, and the other shoots way up past 3.8 degrees. What do those two realities actually look like under the hood?
Well, the 1.5 degree path is our stabilized neighborhood. Achieving it requires a grid powered by 92% renewable energy. And we'd need to reach net zero carbon emissions, which preserve their biodiversity and air quality. But that higher 3.8 degree path, that pushes carbon dioxide levels up to 850 parts per million.
Wait, 850? What are we at right now?
We are hovering around 420 right now.
Oh, wow. So we would be more than doubling the heat-trapping blanket around the Earth.
Precisely, doubling the blanket. And that explains the massive frequent heat waves. But, there's also a 1.8 meter sea level rise projected for that higher path.
Yeah, I saw that in the brief. How does extra heat translate into, nearly 2 meters of water?
It comes down to a mechanism called thermal expansion. So at higher temperatures, we aren't just melting glaciers and ice sheets.
So that is happening incredibly rapidly.
Right, very rapidly. But the ocean water itself actually physically expands as it warms up. The warmer the water, the more volume it takes up.
Just pushing the sea level steadily higher into our coastal cities.
Yeah, and we don't even have to wait for that 3.8 degree future to see the mechanics of this in action. We are feeling the heat accelerant right now. If we connect this to the bigger picture, current warming levels are already acting as a massive multiplier for natural extremes.
Like the severe droughts we keep seeing on the news.
Exactly, because the added heat evaporates more moisture from the ground, driving those droughts, which then fuel intense wildfires. Simultaneously, a warmer atmosphere holds more water vapor, leading to massive sudden floods. We are already seeing the immense strain on our global food supply.
And rising heat stress deaths, too. So because of the carbon already pumped into the atmosphere, this car we're driving has a massive braking distance. We have to start hitting the brakes today just to safely stop decades from now.
Which brings us to a very strict countdown clock governed by physics. That clock has two main alarms, 2050 and 2100.
Okay, let's look at 2050 first. That is the deadline decade to hit net zero, right?
Yes. And net zero simply means any lingering emissions we release are perfectly balanced by physically removing carbon from the atmosphere.
Right, balancing the scales. And if we fail to hit that balance by mid-century, we just bleed into that second alarm, 2100.
Exactly. By 2100, the compounding effects of climate momentum take over. A lack of strong action now pushes that end-of-century warming toward 2.5 or 3.0 degrees.
Which triggers a total reshaping of our coastlines and forces massive human migration.
Yeah, and upends global agriculture. You'd even see the collapse of global insurance markets because the risk of disaster becomes completely unquantifiable.
But hold on, let me challenge that timeline for a second. If 2050 is the deadline to hit net zero, but massive emissions are, still happening right now, isn't 1.5 degrees already a lost cause? Haven't we essentially blown past the speed limit?
What's fascinating here is the concept of a temporary overshoot. Many climate models acknowledge that temporarily passing the 1.5 degree mark is highly likely.
Wait, really? We might pass it.
In fact, we might already be crossing it in our annual measurements. But it is not a pass-fail scenario. Limiting the duration of that overshoot is everything.
Because we can still pull the car back.
Yes. If we peak at 1.6 or 1.7 degrees, we must aggressively pull temperatures back down using massive reforestation, soil carbon sequestration, and direct air capture technologies.
Right.
A 1.6 degree world is vastly safer than a 1.8 degree world. Every fraction of a degree determines how much permanent damage is done while we are over the line.
So what does this all mean? It means this isn't just about saving polar bears. This is civilization level serious. It is a long-term multiplier of floods, instability, inequality, and conflict.
It really is. This raises an important question about how we view the crisis. It's a continuous damage scale. Every tenth of a degree avoided literally saves lives, stabilizes economies, and preserves entire ecosystems.
Which brings us to a final thought for you to carry with you today. If we stop viewing climate change as this terrifying pass-fail test, one where we feel like we've already failed.
Right, getting rid of that doomed mindset.
Exactly. And instead see it as a continuous damage scale, where every fraction of a degree is worth fighting for. How does that shift how you view your own daily actions and the policies you support? Because at the end of the day, we are all driving through the exact same neighborhood.
We really are.
And every single tiny tap on the brakes matters.